Okay, 1.2. Solving and graphing inequalities, and we're also going to write them in interval notation. So, inequalities. Inequality has more than one answer and uses the following symbols. Now, most people refer to this one as the less than symbol. That is because in English we read left to right. So we say 2 is less than 5. But we could also read that the other direction and say 5 is greater than 2. 3 is greater than 1. Let's make it 3 is greater than negative 1, which is still true. But negative 1 is less than 3. Negative 5 is less than 11. We could go the other way and say 11 is greater than or equal to negative 5. Sorry for the shaking. They're apparently walking on the roof. This part here, the line, is the or equal, which is why we can have a statement like this. 3 is greater than or equal to 3. It is true. Now, to graph variable inequalities using number line with open dots, we use those for the less than or greater than, and we use closed dot for the less than or equal, greater than or equal symbols. And remember, if you divide or multiply by a negative number, you need to switch the inequality around. So in this case, we know we have to divide by negative 2. And we know that negative 2 is going to cancel, leaving us an x. And we know 6 divided by negative 2 is negative 3. But remember, this symbol here, since we divided by a negative, needs to switch. X is now greater than negative 3. If there's no solution, we put the null set, empty set symbol. And x is less than 2 is the same as 2 is greater than x. Sorry. Now, interval notation. Interval notation uses parentheses and brackets. Parentheses are for open dots, and brackets are for closed dots. Remember, these are greater than or less than, and this is our less than or equal, greater than or equal symbols. So we're going to graph them first as an inequality, and then convert it to interval notation. So, in this case, x is greater than or equal to negative 1. It's starting at negative 1, going to the right, which is greater than, and it's greater than or equal because it's a solid dot. Now, interval notation says it's going to start at negative 1, including the number negative 1, solid dot, and going to the right towards positive infinity. That's interval notation. From one number to another, even including infinity. Now, in this case, we have x is less than 3. Open dot, less than. But in interval notation, it's going the other way, so 3 is on the right side because it's going towards negative infinity. And we use a parentheses because it's an open dot. Now, number 3, the inequality is a little bit different. X is less than 5, but greater than or equal to negative 5. Interval notation just says it goes from negative 5 to 5, not included, included. Number 4, we're now going to go the other direction and say, what is this like on a graph? Well, from negative 8 to positive infinity, which means it's going to the right, and this bracket means solid dot at negative 8, and going to the right forever. Some of you might want to, instead of having to color over the line, you can also put it above the line, like so. And that's fine. In which case you would just put a dash at negative 8. Okay, this one is starting at negative 1. And it's going to left towards negative infinity with an open dot. And instead of shading, you can just do that above the line. Okay, 6. Solve and graph each inequality, then write in interval notation. two ways to go about this. You can move the 6 over and then divide by -3, which means we're going to have to flip the symbol. Or we can move the -3 and it'll be positive and already be on the correct side. So it doesn't really matter. You can do it either way. Some people like to avoid the negative. So I'm going to show it the first way, -6 on both sides, which gives us -3x less than 6. We divide by -3, which gives us x -2. We have to switch the symbols. X is greater than -2. Now, just for argument's sake, let's say I want to move this 3x over, which gives me 6 is less than 3x plus 12. Now I subtract the 12, I end up with 3x is greater than -6, or -6 is less than 3x. I divide by 3, and look what I get. -2 is less than x, or x is greater than -2. These are the exact same statement. What gets confusing, though, if you do it this way, is interval notation, because you always want to think about it in comparison to the x. Always read from the x for interval notation. So it's x is greater than -2. So -2 greater than positive infinity. So that's the only problem with doing it and solving the x on the right side, keeping it positive, is you got to remember for interval notation, always read from the x, from the variable. Okay, now I could send this -4 in, but it's just going to give me bigger numbers. I'm going to get rid of it right off the bat. But look what happens. I divide it by a negative, which gives me 4x plus 2 is greater than or equal to positive 6. Negative divided by negative is positive. Now I'm going to subtract 2 and get 4x is greater than or equal to 4. Divide by 4, and I get x is greater than or equal to 1. So 1 greater than or equal, I use a bracket. It's greater than, so it's going towards positive infinity. Okay, we have fractions. We have two ways of going about this. We can move our fractions, or we can get rid of the fractions. It makes no difference. If you want to get rid of the fractions, you multiply every term by 3. When that happens, cancels here, leaving me n, plus now 30, greater than or equal to, the 3's cancel, leaving me 2n minus 12. Okay, now I can think ahead again and say, well, if I move 2 n's over, I'm going to get up with negative and have to divide by -1. Or I can just subtract 1n and get 30 is greater than or equal to n minus 12. Add 12 to both sides and get n is less than or equal to 18. If you're more comfortable, you can just rewrite it this way, which will help with interval notation. So we put our 18. Since it's less than 18, it's going towards the negative side, towards infinity. So I know we read 18 is greater than or equal to n, but you still got to always read it in terms of that n, the variable. Okay, so I'm going to get rid of my decimal by adding 0.12, which gives me 0.15y is greater than 3.98. Now all I'm going to do is divide by 0.15. So 3.98 divided by 0.15 is y is greater than 26.53, repeating. and that's okay. So we have 26.53 repeating. It's greater than, so we're just going to use parentheses, and it's going towards positive infinity. I just realized I forgot to graph these. I apologize to you. So here on, going back to number 6, we put a -2. It's going towards positive infinity. Is an open dot that way. For number 7, it's 1 solid dot going towards positive infinity. 18, solid dot, because it's less than or equal, and it's going towards negative infinity. And now caught up on number 9, 26.53 repeating. It is an open dot going out towards positive infinity. Okay, compound inequalities. Last thing we're covering. Compound inequalities are two simple inequalities joined by an and or an or. And problems look like this, where it's in between. Sorry, they're walking in on the roof. And what we really do is, instead of solving both sides of the equation, we just literally do everything in 3 spots. So I'm going to add 8 to both sides? No, I'm going to add 8 to all 3 sections. Just a change in vocabulary. 8 minus 2 is 6. The 8's cancel. 3x. Less than. 10 plus 8 is 18. Now I divide by 3. I do that in all 3 places. That gives me 2 less than x less than 6. So it's all less thans. So I just put a 2 and I put a 6. X is greater than 2, but less than 6. And how's it look in interval notation? It goes from 2 to 6. Open dot means parentheses. Or problems, you just solve them separately. So I'm going to minus 7, minus 7. Negative 2x is less than or equal to negative 4. I'm going to divide by negative 2 on both sides. Remember to flip the symbol. That gives me positive 2. So x is greater than or equal to 2. Over here, minus 5. 3x is less than negative 3. Divide by 3. Now, since I'm dividing by a positive, yes, there's a negative, but I'm dividing by a positive, so x is less than negative 1. So, we have number 2, and it's greater than or equal. And we have the number negative 1, and it's less than. That will look like that. So greater than or equal to 2, or less than negative 1. Now, how do we do that? We just do 2 separate notations. I'm going to write it below, just a little bit more space. So negative 1 towards negative infinity, 2 inclusive towards positive infinity, and we're going to use the union symbol for or compound inequalities, another name for it. We use the union symbol. There you go.